that is polarization. Okay. From next class we will start with this. So what is polarization? Uh, it is the locus of the electric field as seen. So for our electromagnetic waves, we have seen that there is an electric field component, there is a magnetic field component, and both the electric field and magnetic field components, they are perpendicular to each other, and the direction of the propagation of the electric wave is perpendicular to both the electric and magnetic. So this much we have seen in our previous experiments. Now, polarization of a EM wave, it is generally defined in terms of the electric field. It tells us about the locus of what the electric field traverses as seen along the direction of the propagation. And there are three major types of polarization we will see. First one is linear. Whatever EM waves we have discussed so far, they are all linear. Second is circular. And third is elliptical. So we start with linear. So when an EM wave is said to be linearly polarized, it is said to be linearly polarized is A. Electric field has only one component, or B. It has two perpendicular components which are in phase shifted by an angle n pi, where n equal to -3, oh sorry, -3, an integer. So from minus infinite to infinite, all the integers. So let us see this thing in a bit. So far is it okay? So far is it okay? Any questions so far? Either the field will have one component or it can have two components, but they should have a specific phase difference, and that specific phase difference is an integer multiple of 1. Okay? If either one of these components holds, it is linear. Is it okay? Now what is why it is linear? Let us see this. Okay, one thing I mentioned is polarization is seen from a direction that is along the direction of the propagation, not opposite to the direction. Okay, that is why we will use a little bit of unconventional coordinates for this particular case. For example, the coordinate systems which we have used so far is like this: x, y, and z is how? It is towards the plane or away from it. If x and y is like what I have drawn, z will be towards the plane or away from it. Towards your screens or away from the screens?
Towards the screen.
Towards the screen. Okay. Are you sure?
Sir.
What's what?
Sir, I mean coming out from the screen.
Exactly, coming out from this. So it will be like this, there is like this. The problem of using this conventional system is that if we see this and if we assume a wave that is propagating in the plus z direction, then we will see it in a way it is coming towards us, right? So we cannot see it along the direction of the propagation. What is the problem? If we use this particular coordinate system and we assume a wave that is propagating in the plus z direction, then that wave is coming from the screen and hitting us on our faces, right? Right. So if you have to see it along the axis of propagation, we have to see it from behind, going back from behind of our screens, which is not possible. Right? You understand the problem? You understand the problem?
Yes, sir.
Okay. So for this course, this particular circle part, we will use this x, this is y, and z will be in which direction?
Going into the
Going
surface.
in, absolutely. And this suits our purpose. We can see it along this direction. This particular coordinate suits our purpose. Agreed?
Yes, sir.
Okay. All the others? All the others? Agreed? Anybody else?
Yes, sir.
Okay. So let us consider the waves which we have seen right in the beginning. For example, E Z, that is E naught e to the power of minus j beta z along I direction. Okay. This we have seen. What will be H? H will be E naught to the power of minus j beta z j beta naught. Let us assume it is backward. Okay. Agreed? But we will focus only on E. Okay, H is not important for this particular. We will focus only on E. But H is there, no problem. Right. Now, and what will be in terms of vectors? The same thing. E Z will be the real, as we have the real part of e to the power of z j omega t or E0 cos of omega t minus beta z. And you agree with this?
Sir.
Now we focus on the xy plane. We focus on the xy plane or z equal to 0. So that means z. So E of 0 t, this will be E0 cos of omega t I. Is it okay? On the xy plane, z is 0. So E will be this. Okay? Do you agree?
Yes, sir.
Now tell me what happens when t is also 0. And what is E 0 0?
E naught.
E naught. Absolutely.
E naught I.
E naught. Correct. That will be somewhere here on the xy coordinates. If we assume it to be E naught here, that will be somewhere on the x-axis. And note that we have taken the x-axis in a little bit unconventional. Usually the x-axis is horizontal, we have taken it forward. Is it okay? So if you plot that E dot 0 0, it will be plotted a dot somewhere there on the x-axis. Agreed?
Yes, sir.
Now tell me, what is E? Say when t is equal to 2 by omega, and this is 0. or say 2 by 2. Let's say 1 by 2. 1 by 2. What will be? Z stays 0. Throughout our discussion, Z stays 0. Z T by T. So what will be omega E naught here? When T is 1 by 2 omega. Or beta.
E naught cos of half.
Cos of half. So it has cos of half. Omega is equal to what? Omega is equal to 2 pi f. What? 2 pi by t. Omega is equal to 2 pi f. That is 2 pi by say t naught. Where t naught is 1 by f. So what will it be? At t naught by 2. Or say that t naught by so it will be pi by 2. T naught by 8. T naught by 8. Then it will be 2 pi by t naught into t naught by pi by 4. So what will be the value? If t is t naught by 8, then omega t will be 2 pi t naught into t naught by 8. That will be pi by 4. Right? And cos of pi by 4 is 1 by 2. So this should be e naught I by root 2. Okay? Okay? Is it okay? Is this, do you agree with this? If t is equal to t naught by 8, then this becomes this value. Is it okay?
So can you please repeat this part?
Yes, sure. This will be 0t. Getting z, right? So this will be 0. E of z 0t was E naught cos of omega t. Do you agree? This was given. This was given. Is this okay? E of 0t is called E naught cos omega t. Is this okay?
Yes, sir.
Right? And omega is 2 pi f, that is 2 pi by t naught. T naught is 1 by f. T naught is the time period. Now, what will be the value of E of 0 T naught by 8? That will be, let us put here E naught cos of 2 pi T naught into T naught by 8 I. So T naught gets cancelled. We have 2 gets cancelled. So E naught cos of pi by 4, and cos of pi by 4 is 1 by root 2, right? This is 1 by root 2. That is what I have written. Is it okay? Is it okay?
Yes, sir.
So this was there at t equal to 0, and this was at t equal to t naught by 8. So this is t naught by root 2. Now tell me what will be. So as t is moving, this value of e, it is moving in this direction. It is going down. As t is increasing, the value of e is going down. Agreed?
Yes, sir.
Okay. Now tell me what is the value here. What is the value of this vector and this vector?
0.
0. So it will be here. It will be here. It will be here at the origin.
Yes, sir.
Let us move on. So this is still going down, right? Let us carry on. Let us continue the conversation. Now, okay, what is the what is the 3 denoted by 8.
Sir, minus E0I.
Minus will be there, but is it E0I? What will be the value?
Minus C0I by root 2.
Yes, minus E0I by. So it will be somewhere here. It will be somewhere here. Agreed?
Yes, sir.
It's going down, still going down. Now what happens now? What happens?
Sir, minus C0.
Minus is it will be here. What happens now? So it is continuously going down, right? From E0 it went back down as down up to minus. Now what happens? 5t by 5t not by 8. Of course I know. What happens now?
Sir, minus C by root 2.
Absolutely. Right. So back here. So this is also for t equal to 5t not by 8. And if you go on with this analysis, you see that it goes up again up to here. Okay. When t is equal to capital T naught, then again it goes down like this. Is this okay? Like it starts at the top, it goes to the bottom, that is minus E0 I. Then it once again goes up to the top to E0 I. Then it again plunges to the bottom. You understand with this? Is it okay?
Yes, sir.
Right. So how is the tip? How is the value of tip of the electric field moving? It is moving along a line which is along the x-axis. As the time progresses, the tip of the electric field is Ittafaq is in our class, right? Ittafaq Iqbal is in our class.
Yes, sir.
Yes. So this as the time moves, the tip of the electric field is moving along a line from plus E0 to minus E0. Does it is it moving? Is it going anywhere here or here or here? It is not going. It is staying on that line and it is moving along the line from top to bottom, then bottom to top, again top to bottom. So it is moving in a linear fashion. Get my point?
Yes, sir.
So this is an example of a linear potential. Because the tip of the electric field, it is moving in a linear fashion. The electric field is moving in a linear fashion. You understand? However, this movement is not necessarily be along a particular axis. Okay, in order to it to be linear, in this case it is along the x-axis. In some cases it might be along the y-axis, as we have discussed. But it is not necessarily that it will be along x-axis or y-axis. It will be along a line to be linear polarization, but that line may not be the x or y axis. Okay, get my point?
Yes, sir.
Yes, sir.
Let me give you an example of such a case where it is not along x or y axis. We go again consider the same coordinate system. This is my x, this is my y, and the z is going towards our x. Okay, and the wave we consider is like this. And directly, okay, let us start from the fifth. E of zt, that is E naught, it will be power of minus j beta z I plus or minus, let us say plus for our example, but minus is also perfect. E naught e to the power of minus j beta z g. Can this wave, can this, first question, can this electric field be the electric field component of an electromagnetic wave that is propagated in the plasma? Yes or no? First question is, for a wave, plane wave that is moving in the plus z direction, can this be for such a wave, can this be the electric field component? Yes or no? If yes, then why? If
And,
no, if yes, then
and
what is
no,
the
because
no? Why not?
sir, because one component of the electric field is moving along the y direction,
One component
and
electric field is in the y direction and another is in the x. So it cannot
uh,
be. Okay, okay, fine.
and if the wave is moving in the z direction, then and the electric field is in x direction, then the magnetic field has to be in z direction. Sorry, y
Y
direction.
direction. Acha. Okay. Okay. Fine. So he is saying, Nino is saying, cannot. Anybody who agrees or disagrees, both types of answers are welcome. Agreement is welcome. Disagreement is welcome. Anybody else who wants to say something? First question is whether this EZT can be the electric field component of a EM wave that is moving in the Z direction. If yes, then what is the corresponding answer? If yes, then what is EZT? And if no, then we are not worried. Anybody who wants to contribute? Yes or no? Both answers are right. Anybody who thinks that it may or may not be? Anybody who wishes
So
to say
can
something?
we get
Hmm. If somebody was saying
so
something,
can we
can we?
get H by
Each by. First question is whether this can be electric field component, yes or no. If yes, then only we'll bother about it. If no, then there is a end of it. Can this be the electric field component of an EM plane wave that is propagated in plasma? This is the first question. Miller has said no. What do you think? Yes or no? Yes. Okay. So if yes, then what is H? Then you can think about it. What is H vector? H vector would be E0 by theta 0. We assume it is vector. Okay? For our confidence. What do you think? Is it feasible? Is it feasible? Actually, it's Z only. No T. We have no Ah, is it feasible? Let us see what are the conditions for a plane wave. First condition is that the electric field and the magnetic field, they must be perpendicular to each other. Right? Let us see they are perpendicular. Yes, divided by each other. Let us see whether they are perpendicular to each other or not. What is the best way to check that? What is the best way to check whether two vectors are perpendicular to each other or not?
Taking cross product.
by dot product.
Dot product is better. That will be easy. Let us take the dot product of Z and X. What we get Z and dot X. So we have I dot J, that will be 0. I dot J are perpendicular. Agreed? This dot product will be E naught square eta naught e to the power of minus 2j beta z I dot j minus, sorry, plus E naught square eta naught e to the power of minus 2j beta 0 j dot j minus E naught square eta naught e to the power of minus j to bz I dot I, and finally E naught square eta naught e to the power of minus 2j. This is j dot I. Getting this? All of you getting this? Any did I make a mistake? Let's check. Just check. Did I make a mistake somewhere? Or is it correct?
It's okay, sir.
It's okay. Now see carefully that I dot j is 0 and j dot I is also 0. Right? I dot j is 0 and j dot I is also 0. So these terms cancels. They are 0. And j dot j is 1 and I dot I is also 1. So they also cancel. This is 0. So they are indeed perpendicular to each other. So the first condition is satisfied. E and H, they are perpendicular to each other. Is it okay? Is it okay?
Yes, sir.
What is the second condition? What is the second condition? That both E and H will be perpendicular to the direction of propagation. Right? Is it okay? Both E and H should be perpendicular to the direction of propagation. Now E is the
Yes,
X and
sir.
J direction, and the propagation direction is the K. It's for plus Z, so it will be K. So both I and J is perpendicular to K. Agreed? Agreed?
Yes, sir.
Similarly, same logic applies for H. So both E and H perpendicular to the K. So it's fine, both the conditions are satisfied. Right? So this can indeed be the E component of a plane wave that is traveling in the classic direction. All of you agree? That case is agree?
Yes, sir.
Okay. So how will the we do the same thing. What is the E? What is the vector? What is this vector E of Z? That is simply the real part of what we have discussed. Phasor of Z times e to the power of 0 omega. So this will be E naught cos of omega t minus beta Z I plus E naught cos of omega t minus beta Z G. Okay, agreed?
Yes, sir.
Okay. So we do the same thing what we did for that omega is equal to 2 pi s, that is 2 pi, sorry 2 pi by t naught, that is 2 pi s, f is 1 by t naught. So which Shenmugta is from our class. So we again take the xy plane, that is z is 0 and let us take x is also 0. What is the value of E of z? Let us make it a bit more general. Let us make it E1 and E2. Okay, let me make it more general. The amplitude of the both components are different. So what is E of 0, 0? What is E of 0, 0?
E1I plus E2J.
E1I plus E2J. Right. So somewhere here where this is my E1 and this is my E2. So it will be this point. Okay, do you agree? It will be this point on our x coordinates.
Yes, sir.
Yes, sir.
What will be this? What will be this? Same thing. 0 T0 by 8.
So E1 by root 2I plus E2 by root 2J.
This, this,
Yes,
somewhere here. But note that the slope of these 2 points, as per from the origin, they will be the same. Like if I join these 2 points, then this angle is same 0. So they will be on the same line. What will be this? What will be this?
0I
0.
plus 0.
Absolutely. 0 times E1I times E2G. It will be here. And if you might have guessed, if we go on, then it will go here up to this point, which is minus of E1I plus E2J, and then again it will go up, but it will follow one straight line. This straight line is not along x-axis, this straight line is not along y-axis, yet this is a straight line. You agree?
Yes, sir.
So this is another example of linear polarization, linearly polarized wave. And this is the first point. And second point, which I told you in the when we discussed about the plane waves, that the plane wave along z or z axis can have both x and y components. This was just for our convenience we assume only one, right? But it will not have any z. So this is an example of a linear polarized wave. Okay. Had this been minus, it would have been still be a linearly polarized wave, no problem. Understand the point? Had this been minus of this, minus of this j, it would have still been, what I mean is, This would have still been a linearly polarized wave. Do you agree with this or not? Still linearly polarized. Okay, because the tip of the E field makes a line as T passes. Okay, so this is an example of linear polarization. Is it okay or not? Any questions regarding linear? The circular one will give you next. Circular wave. Any questions regarding linear polarization? Whatever we discussed so far. Anything? Any questions you want to ask? Any questions? Anything you want to know? No questions. Okay. Let me take your attendance and we will come back to this.